All right, so 3.1 continued. We've looked at functions. We've reviewed what function notation looks like. We've talked about what domain is. Domain being the input values. So these are the input values. And we're going to look at functions today that have restricted domain. So on the left, I have written out the rules for inputs into a function. So it says, if the function is numeric, the number values must be real. And we're going to review imaginary numbers soon so that we can graph them. So we can only graph real things. They cannot break the math rules for the functions. And these are the rules that we know. There's 2 rules, but number 3 is a combination of the 2. All right, so the 2 rules. In black are things that are allowed, and red are things that are not allowed. So number 1, 0 in the numerator is allowed. 0 in the denominator is not allowed. Number 2, a negative and an odd radical is allowed. A negative in an even radical is not allowed. And number 3, a combination of the rules 1 and 2. If you get 0 in an even radical and in the denominator, then that's bad. That's not allowed. So let's look at these rules specifically with examples so they'll make sense for you. Okay, some examples. So let's look at some that everything's allowed. So these are all domain problems. And let's say we have a polynomial. And we defined that last year as something like f of x equals 2x cubed plus 3x squared plus 4. So this doesn't have, over here in our 2 things that are allowed or not allowed, it doesn't have a numerator denominator. It's not a fraction. And number 2, it doesn't have any radicals. So this being a polynomial function with positive exponents is all real numbers for domain. So what does that mean? It seems like kind of an arbitrary thing, but that means that if you made an XY chart, you could plug in anything you want for X. You could plug in -1, -2, 0, 4. You can plug in any number and take it to the 3rd power and multiply it by 2 and figure out what Y is. You can even plug in decimals or other fractions. You can plug in anything. All real numbers could be plugged into an XY chart. But if we're going to break something, then let's look at breaking rule number 1. So having a numerator denominator. So we're talking about fractions here. So if example 2 says, okay, let's have g of x, and let's make it a very simple fraction. Let's make it 1 over x. So if we made an XY chart, we could plug in a whole bunch of numbers. But the one number that would break it right here, the number that would make the denominator 0, is 0. So we can make an XY chart and put in -1 and -2 and +1 and +2, but we can't plug in 0 because this is not allowed. So we can't put in 0. We have to say that the domain for this graph is x cannot be 0. That's the number that makes the fraction 0 in the denominator. Along those same lines, let's look at something a little more interesting. So 1 over x minus 2. So this is going to be about rule number 1 with fractions. You're going to figure out what would make this equal to 0. You can actually solve it. You could say x minus 2 is not equal to 0 and figure out what that value is. Many of these you can figure out in your head. If you put a 2 there, 2 minus 2 would be 0. And so 2 is the number that's not allowed. But you can also solve it. So x minus 2 is not equal to 0. Add 2 to both sides. X is not equal to 2. So we're solving an inequality. It's not equal to. So when we graph this, we're not going to have a value at 2. You can't plug 2 in. It doesn't have a value there. That's what limited domain means. And the function that is implied here, being a fraction, this domain is limited because it has a denominator. So example 3 is going to be along those same lines. Let's do h of x equals 3 times x plus 2 over x squared minus 4. So again, this is a fraction. We're thinking about rule number 1, which means we can't have 0 in the denominator. We need to factor this to figure out what's going to be equal to 0. So x minus 2, x plus 2 can't be 0, not equal to 0. We can solve each one of those, x minus 2 and x plus 2. So x cannot be positive 2 or negative 2. Even though this simplifies to be 3 over x plus 2 over x minus 2, x plus 2, and these cancel, from the beginning, you can't plug in 2 and negative 2. So domain is from the very first step. Even though these cancel, and this is the simplified version, we're still not allowed to put in negative 2 because it would break the original function. So in the work that you have, for homework, for practice, you're going to notice whether it's a polynomial, which would be all real numbers, doesn't have any rule breakers, whether it's going to be a fraction, and you have to set the denominator equal to 0 in order to figure out what it can't be in the denominator, or in our last example, well, not our last example, our last big rule is going to be radicals. So looking at radicals, example 4, let's look at a simple one to begin with. Let's just do the square root of x. And let's compare it to, actually I'm going to compare it a different letter, the cube root of x. If you take this and graph it on your calculator, just real quick, I'm going to show you what it looks like. This one goes like this, and this one goes like this. So visually, it's easy to see what the domain and range are. For this one, the graph starts at 0. It doesn't have, there's nothing over here in the negatives. But over here, we have positive x's, and we have negative x's, and we have a 0 value. So cube roots have a domain of all real numbers. You can write all reals, you can write that special R. So cube root or fifth root or seventh root, these are odd roots, are allowed to have negative numbers because when you take a negative number, let's do something very simple, negative 2 times itself 3 times, and I wrote 3 instead of 2. I do that, sorry. If you have an odd number here, like this is the third root, meaning there's 3 of them, you end up with a negative value. So this is negative 2 times negative 2 is 4, times another negative 2 is negative 8. So negatives are okay. So if you go backwards and take the cube root of negative 8, your answer is 2. So negative radicands can have a cube root. But over here we can't. If we say an XY chart, let's plug in stuff. If we plug in 1, the square root of 1 is 1. If we plug in 4, the square root of 4 is 2. If we plug in 9, the square root of 9 is 3, and we could graph those things. Here's 1, 1, 4, 2, 9, 3 would be here. But we can't plug in negative 1 because the square root of negative 1 is imaginary and it can't be graphed. So here's where rule number 2 says negative and an even radical is not allowed. So we have to solve this one again for 0. 0 is allowed, 0 is fine. The square root of 0 is 0 because 0 times 0 is 0. So we're going to do the same thing here. We're going to solve this like we did in example 2 and 3. We're going to say x cannot be negative. So x must be greater than or equal to 0. 0 is okay. All right, let's do some more like that because those are harder than the fractions, I think. So here we go. H of x equals the square root of x minus 4. So what do we need? We need this is okay to be equal to 0, but it cannot be negative. So what values would make this 0? 0 is fine. And then what values would make it negative? So what we're going to do is we're going to solve it to be equal to 0 because that's okay. So x can be 4. Let's check that out. The square root of 4 minus 4 is the square root of 0, and that's good. But then we're going to do a number line test, and we're going to put 4 on a number line because it's good. And we're going to test values on the right, and we're going to test values on the left and see what works. So a good number to test on the left of 4 would be 3. The square root of, we're plugging it in, here's our original function, x minus 4. We're going to plug in 3. 3 minus 4 is going to be the square root of negative 1, and that's not allowed. So numbers over here are not allowed. And if we plug in 5, we'll have the square root of 5 minus 4, which is the square root of 1, which is allowed. So we can say that x can be equal to 4 and greater than 4, and that is our domain. So make sure you write down these rules and try your practice problems and come to class with questions.